is not congruent. Or you could say not equal. Okay, for number 15, they ask you to do several things with that function. First of all is to draw an accurate graph. So if you notice, I made a table of values. Notice how I put the numbers 0 through 4 on the x column. And the reason for doing that is because I noticed that the inflection point was 2, positive 2, because remember it's the opposite of what you see here. So 2, 2. So that's my h and my k. So h is 2 and y and k is 2. So that's the point that goes in the middle. Okay, so I put it over here and I put IP for inflection point. So if I put a 2 in the equation here for x, then I work it out, I'll get the 2 for the y. Now for the other 4, I can just plug them in. So if x is 0, so I'm going to put a 0 here. So 0 minus 2 is negative 2. I'm going to cube negative 2, and so I get negative 8. I'll put the work up here. Negative 8 plus 2 gives me negative 6. And then if x is 1, I'm going to again replace the x with a 1. So this is 1 minus 2, which is negative 1. When I cube it, it stays negative, so it's negative 1 plus 2, which is 1. Okay, then I plug in the 3. So I put a 3 here. So 3 minus 2 is 1. 1 cubed is 1. 1 plus 2 is 3. Okay, and then last 4, the last x value on my table is 4. So again, I'm going to put a 4 here. And 4 minus 2, right here, 4 minus 2 is 2. I'm going to cube the 2. 2 cubed is 8. 8 plus 2 is 10. Okay, I may not have enough room for, well, just barely, actually. Okay, so I'll plot the points. And again, the reason I made a table is because it says accurately. So I have to make sure I have these 5 points, make sure they're placed in the right spot. So it's not just a sketch, so they want an accurate graph. So 0, negative 6, 1, 1, 2, 2, 3, 3, and 4, 10 is to the very top, 8, 9, 10. About here. Okay, so connect the points. And the one on the top. There you go. And so that's it. So it says, what is the y-intercept? So the y-intercept is where the graph crosses the y-axis. Well, we knew from the table, we knew even before we graphed it, we saw that the y-intercept was negative 6. So for part A, y-intercept is 0, negative 6. Okay. For part B, with the ruler, draw the line through the inflection point in the y-intercept. Okay. And now it's hard to use a ruler with a tablet, so I'm just gonna freehand it as best I can. So it says from the inflection point to the y-intercept. So that means that the line goes something like this. And then with the other point, what other point on fx does the line pass through? So again, if I extend the line, the green line, to the top, because it wants to know what other point it passes through, it would actually pass up here through 4, 8. So B is just draw the line we did, and then C is what other point on f of x does the line pass through? It passes through 4, 8. Okay? And then calculate the distances between the inflection point and each of the 2 intersection points. So what they want us to do is find the distance between this point right here and this point right here. and then do the same thing up here. Now the distance formula, you are not responsible for knowing it, but this is a good place to review it, so don't get nervous if you forgot what it was or if you don't know how to plug in the numbers, but just know that it's review, but it's not going to be tested. Okay, so they want us to find the distance from here to here, and then from here to here. Well, one way you can find the distance is by Pythagorean theorem. So I know you learned about that last year, or last year or the year before. So Pythagorean theorem says that if you have a right triangle, so let me get a different color pen. So if you have a right triangle, and I'll draw it in blue, right here. This is my right angle right here, and so this is 2 units, and from here to the bottom that's 6, negative 6 plus 2 more, so this is 8 units. So remember Pythagorean theorem says a squared plus b squared equals c squared, where c is the hypotenuse, or the longest side of the triangle. So then a is 2, so it's going to be 2 squared. B is 8 squared, and that gives me c squared. So 4 plus 64 is c squared. 68 is c squared. So we're going to take the square root of both sides. So square root of 68 equals c. So that's the distance from the inflection point to the point 0, negative 6. And then when we do the same thing to the top, again I'll continue with the blue. Again, from the inflection point, if I go across and then I go up to that point, that pink point, and then draw the hypotenuse. Here I have the right angle. This is 2 units long, and this, if you count the squares from 2 to 10, that's 8 units. Notice how it's the same numbers, 2 and 8. So doesn't that tell us that it's the same distance? Okay, so I don't have to go through the work. It's the same work as I have right here on this side. So I notice that both sides are going to give me the square root of 68.